we are continuing on with this rose curve. We're going to look at it a little bit differently. And so on page 181, example 4, we're going to talk about this same equation that we did yesterday. Let's put on here what the interval is. That's going to be important on all these questions. What part of the x-axis or polar axis are we using? And in this case, it was just 0 to pi. Okay? And we're going to answer some questions about this graph on very specific intervals. So if you look, this row is all of the intervals of theta from 0 to pi, just broken up into pieces. And we're going to be answering the same questions that were in our circle XY chart, our circle chart here. These are the same questions that we're going to answer here, but on a much more difficult graph. So if you remember, when we answered these questions yesterday about this graph, it was pretty simple to say what was positive, negative, increasing, or distance from the pole. When you look at a graph like this, though, what's positive, what's negative, is it increasing or decreasing? It's really hard to tell when we're doing petals. So what's really, really cool is something I talked to you about a few days ago, last week maybe, where you could actually put this in your equation as a plain old boring rectangular graph, an x and y axis, where this is just a cosine graph with an amplitude of 4. It's an up, middle, down, middle, up. So yesterday, we put this in our equation, in our calculators in polar form. Today, let's do it in rectangular form, and that is going to make these questions so much easier, because it's the same information, just altered a little bit. So do me a favor and clear your RAM. I don't know what people had it in last period, so just go ahead and always clear your RAM. And know that when you clear your RAM, your mode is back in function, which is the plain old XY axis. Remember, if we were going to do polar form, we would go to mode and change function over to polar. But we cleared our mode, cleared our RAM, and so we were automatically back in rectangular form for our graph. So go up to y equals and type this in. 4 cosine 3, and instead of theta, it'll be an x. It's a variable. That's totally fine. And I'm not going to graph it. I'm going to first go and change my window, okay? Remember, when you're in rectangular form, your windows default to 10 in every direction. So the 4 quadrants, 10 in every direction. So we're going to change this to from 0 to pi. Now, it's x-axis in rectangular. It's the polar axis in rectangular. So some slight differences, but we can adjust really easily. Also, if I go to my, you can look at the graph, you can look at the table, but remember, our table is counting by 1. That's what your calculator does by default. It counts by 1s. We want it to count by angles, right? We would love it, we talked about this a lot yesterday, we would love it if it would give us literally pi over 6 and pi over 4 and pi over 3 in the chart. It's not going to do that. It's going to give us angles in decimal form, but it also is going to, well, let's go to that. Go to second table set, and we always want to start at 0 for these because that's what it is, from 0, but we want to change our table. The change in the table, not by 1s, we're going to use, what do you guys remember? Pi over 6, okay? So you're going to literally type in pi divided by 6 here. And remember what this will do for us in our table of values. It will cover every single angle on the unit circle and beyond, except the denominators of what? 4, the 4s, okay? So we know now when we go to our table that this order is 0, pi over 6, pi over 3, pi over 2. Then we start over again in quadrant 2 with our denominator 3, denominator 6, pi, and so on. Okay? So what's not in here is our pi over 4s. If we needed any of those, remember, we would do pi over 4 in our change in table here. But pi over 6 is a very safe bet for most graphs because we hit a lot of those angles. Okay? So what you're seeing here really, really nicely in numeric form is your up, middle, down, middle, up. Look at your r's, which are now the y's on here. So these are your thetas. These are your r's, even though it says x and y. So this is, up, middle, down, middle, up, middle, down. You can see it in the graph as well. Starts up, middle, down, middle, up, middle, down. And so what I'm going to do, for the sake of teaching this to you, and I would like you to do it too, is let's just use this space right here and sketch this graph, okay? So we have 0, pi over 6, pi over 3, right? We skipped over pi over 4, but it's in there somewhere, but that's okay. Then we're up at pi over 2. Then we are at 2 pi over 3, 5 pi over 6, pi. So those are all the points we need. And if I use my table, use my graph, use my knowledge, I know 1, 2, 3, 4, amplitude of 4, right? So I'm going to be up, middle, down, middle, up, middle, down. And you can see your nice cosine wave there. Okay, not very spaced out well, but you get the picture. So what we're going to do is use this graph or your table to answer these questions. Because you don't really have to have the graph. The graph is just really nice. It's going to make this really, really easy, okay? So I'll kind of talk about both. So let's do our first row first. The question is R positive or negative? Deciding that on here would have been really tricky. Like from 0 to pi over 6, our R is positive because we have points in that space. If there's no points there, like up here, that means they shot through the origin, so R's would have been negative. Not impossible, but so much easier here. Look, even though this is an X and a Y axis, you can think of this as your thetas and your R's. So is R positive or negative? Well, if that section interval of the graph is above the x-axis, the R is positive. If that section of the graph is below the x-axis, it is negative. So from 0 to pi over 6, we are positive. From pi over 6 to pi over 3, our radii are negative. From pi over 3 to pi over 2, we're also negative. Then we're positive for a while, right? From pi over 2 to 2 pi over 3, we're positive. 2 pi over 3 to 5 pi over 6, we're positive. And then down below, 5 pi over 6, 2 pi, we are negative. Okay? How could you tell that just looking on here? Well, look, from 4 to 0 is positive, right? You're at 4 going to 0. That's positive numbers. From 0 to negative 4, those would be negative numbers. So you could use a chart to see these as well. From negative 4 to 0, that's negative, right? Picture it on the graph. If you're at negative 4 and you're going to 0, you're under the x-axis, which is negative. Okay, so we could have done it there or here. All right, how about is R increasing or decreasing? Again, we're talking about this wave here. Is the graph going down? That's decreasing. Literally having a negative slope is decreasing. If it's going up, it's increasing. So if you look from 0 to pi over 6, we're going down, also known as decreasing. And we're still going down. From pi over 6 to pi over 3, my graph is not really pretty. From pi over 6, I liked my old one. I made a prettier graph last year. I think my graph is yucky here. Let me use this one. That's better. Okay, so then from pi over 6 to pi over 3, we're still decreasing, right? Negative slope, negative rate of change. Okay, from pi over 3 to pi over 2, we are increasing, going up. From pi over 2 to 2 pi over 3, we're still increasing. And then we're decreasing for these last two intervals, right? From here to here is going down, here to here is going down. So we're decreasing. Super easy to see all of this on a rectangular graph. Now, is the distance from the pole increasing or decreasing? On a circle, it was really easy. As we went from here to here, we were increasing. As we were going from here to here, decreasing. Distance, were we getting closer or further away from the pole? Well, here, same idea, is the distance increasing or decreasing, but our pole is just our x-axis. So, look, and unfortunately, we're using that same kind of confusing term of increasing and decreasing. We're just using it in a different way. I wish they used different words, but they don't. But as we go from 0 to pi over 6, are we getting closer to the x-axis or further away? We're getting closer, right? From here to here. So the distance is what? Increasing or decreasing? Decreasing. The distance is decreasing between as we get closer. So from pi over 6 to pi over 3, the distance is increasing. We're moving further away from the pole, also known as the x-axis. And it kind of just flip-flops from there. We're increasing, we're decreasing. So from here to here, From here to here, we're decreasing, right, getting closer. And then from here to here, we're increasing or getting further away. Decreasing, increasing. Do we see that? Are we understanding the distance part? Tell me if not. I'll explain it another way if I can. You getting it? Yeah? You get it? I don't believe you. Okay, now, are we always going to go to all this trouble to answer these questions? So this is really what I want us to zero in on, is this part of the chart. There's going to be a question in our next homework problem and on your test and on your practice test, your test review, that asks this question without having all this information, all of it. Some of it you'll have, and you'll see what I mean in the next example. And there's a way to answer this question just by knowing these two things. So if you can say if your R is positive or negative, and if it's going up or down, you can answer this question very easily. Okay, so listen, because I feel like it's confusing at first. What I want you guys to think of is the word positive and the word increasing should go together, right? Positive and increasing, and negative and decreasing go together. Okay, so those two concepts, characteristics match up. Positive and increasing go together, and negative and decreasing. In those two situations, when the characteristics match up, your distance is increasing. If you mismatch or mix them up a little bit, one of each, it's decreasing. Let me show you what I mean. So anytime positive and increasing are together, our distance is increasing. Or if negative and decreasing are together, negative and decreasing, your distance is increasing. But look at the other three that are decreasing distance. You're putting a positive with a decreasing. They don't go together. Think of it like that. That's decreasing. A negative and an increasing. They don't go together. That's decreasing. Positive and a decreasing don't go together, so that's decreasing. Okay. There's another way of looking at it, and that's with this chart. This chart kind of confuses me, but like I just with the unit circle, I'd like to give you guys every possible way of memorizing something. So this kind of sums up what I was just saying. If your R is positive and the graph is increasing, the distance is increasing. If the value is negative and decreasing, we are increasing. But if you mix them together, negative and increasing, or positive and decreasing, the distance is decreasing. That is something you have to know, okay? So we'll talk about it again in our final example, but think about the characteristics that match up. Positive goes with increasing, negative goes with decreasing. In those situations, your distance is increasing. Anything else is decreasing. Does it make sense? Somebody lie to me and nod. Is it confusing? Are we confused? I can't tell. We'll see it in our last example here. Our last example of this whole Unit 1, 2, 3 is on our first page of this. So please go here. So we are going to, in this question, here we go, garbage. This is 182. Thank you. Page 182. 3 or 2? I thought you said 183. Okay. I thought you said different page. Green. Oh, I thought you were saying 3. I thought you kept correcting him saying 2 and you were saying 3. You were saying green. Yes, it'll be on a green sheet for some of you. This question, we're going to use our calculator, okay? But I am going to tell you that on your test and on your review, we're going to do a very similar problem with no calculator, okay? But we're going to practice plugging and chugging without a calculator and a chart, just like we could do here, but just it takes longer. We're allowed to use a calculator on this one. In our homework, you're going to see our very short homework assignment. We'll get to practice doing this without a calculator. So just hold. Now, though, we're going to use our calculator to fill in this chart. So it doesn't matter. I proved to you yesterday when you were in polar and today in rectangular that you could put these equations in either one and get the same chart, okay? So you can stay, since you're already in rectangular form, you can just stay here, go to your y equals, and let's type this in. -3 plus 6 cosine theta, okay? Now, remember, our window right now is from 0 to pi, because that's what the last example was. We're filling in a chart for 0 to 2 pi, so I'm going to go ahead and change my window to 2 pi. And I can look at the graph if I want to, but the graph isn't really what I care about, right? I care about the table. Now remember, the table of values, these x values, go in order right around the unit circle, skipping over your pi over 4s. So we're at 0, pi over 6, pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, pi. Okay? So remember, it's always in that order. If you get lost in there, you can always go second, quit, and type something in. Like, am I typing 2 pi? Am I correct in thinking 2 pi over 3 is 2.09? Yes, it is, okay? But when you fill in these charts, especially when they're made for you, notice what we're skipping. What's not in this chart? All of our denominators of what? Besides 4, 6, okay? The pi over 6s are included here. So just be careful when you're filling this out. But also notice why they skipped over the pi over 6s. So 0, we have a radius of 3. At pi over 6, it's a decimal. That's why they skipped it. So you know the decimal ones are your denominators of 6 anyway. But you should be able to kind of start recognizing these the more you work with them, or at least know the order. So we don't want that one. That's pi over 6. Pi over 3 would be 0. Pi over 2 would be -3. 2 pi over 3 would be -6. Let's skip over 5 pi over 6 because it's not in our chart and go now to pi, which is -9. And then you can continue on and fill in the rest. Okay. I typed in that y equals, did you type in 3 plus 6 cosine? Yeah. And then go to your window and change it to 2 pi here. This should be 2 pi. Did you not have that?
Yeah.
Okay. And then the table. Okay. So what we're going to do is use this information to answer some of these questions. Okay. Starting with the average rate of change. Here it is again. Right? We did this a lot back in Unit 1 at the beginning of the year. We'll revisit again with our reviewing time. But average rate of change is just the slope. So don't write this because you don't need to. But back when you did lines, the AROC, we just called it slope, right? The slope between 2 points. Okay? Y is on top, X is on the bottom. You would have said change in Y over the changes in X's. That's back in linear equations. We did it with all types of curves, an AROC formula. So AROC, instead of calling it slope, they call it AROC because it's 2 points on a curve. The AROC changes as the points change on a curve, okay? So in this question, they're asking for the AROC between pi over 3 and pi over 2. So we want to know what's happening with the slope between just these 2 points on whatever this graph is, okay? So there's a formula. And really, you don't have to memorize a formula for this. You just have to really know who's on top and who's on the bottom. So on top is going to be your radii. Radius of your second theta minus the radius of your first theta over the actual thetas. Okay? So you need to know change in r's over change in betas. You want to know r's on top, betas on the bottom. Other than that, it's just basic algebra. Ouch. Okay, so let's do that. If this was a real FRQ, like on an AP exam, I would encourage you to write lots of stuff. So I'm going to just do this example this way. I would say, okay, I want the change in my r's over the change in my betas, which would be the radius of my second angle minus the radius of my first angle. Now remember the order of these, just like with this formula, you can put either one first as long as you match that pattern in the denominator. I did pi over 2 first in my numerator, so I'm going to do pi over 2 first in my denominator. But technically, it really doesn't matter which one you put first, as long as you follow the pattern. Okay? Now, I have those values right here in the chart. The radius of pi over 2 is -3 minus the radius of pi over 3 is 0. And I'm going to need to subtract these. Let's pretend we don't have a calculator and use a common denominator of 6. So that'd be 3 pi minus 2 pi. So -3 minus 0 is -3 over 3 pi over 6 minus 2 pi over 6 is 1 pi over 6. Looks funny, but it's a complex fraction. That's a little baby fraction in a big fraction. And the way we simplify these is keep change division times, flip the bottom fraction. Keep change flip. And we end up with -18 over pi. And that's your answer. We're leaving it in terms of pi. That's not a variable in the denominator. Like, we never leave an x in a denominator. We would have to get it out of a denominator. But pi, even though it's a variable, it's a symbol that stands for something, we know what it stands for. It stands for 3.14, blah, blah, blah. So why am I leaving it in this form and not actually dividing it? Why? What's the purpose of, why do we do this? We in math. Why am I leaving it like that? It's going to be a very long decimal if I do. If I do -18 divided by pi in my calculator right now, I'm going to have to, if I write my answer, I would have to round it. Okay? This is the most exact answer. So be comfortable seeing a pi in the denominator. It's no big deal. A lot of these AROCs, that happens. Okay? And that's what we're doing in our homework today. So I'll do more of those with you in a second. Okay? Don't worry about that. They want us to do another one. We don't need to. Let me just tell you the change in r over the change in theta. I did the math for you just like that, which we'll practice in the homework in a minute. You would have gotten this. Okay, but there's a reason I want you to see it. So same idea. We ended up with this answer if we had used from 0 to pi, these 2 points. Okay, because I want to be able to answer this next question. Is the graph changing faster between this guy right here, this guy's slope, or between the one we found up there? So what we do is we just say, okay, which one's bigger? Which one's absolute value is bigger? So between 0 and pi, this was the slope, but let's think of it as positive, because whether it's going up or down doesn't change anything. And then pi over 3 to pi over 2, we got that slope. Which number is bigger? Whichever number is bigger, that's where your slope is steeper and changing faster. Okay? So since 18 is bigger than 12, f is changing faster between theta of pi over 3 and theta of pi over 2. If it asked, which one's changing slower, you would pick the smaller number. So it kind of goes together. But remember, absolute value. It doesn't matter if it's rising or falling. It's about the absolute value. And final question. This is probably the most important. This is, besides finding rate of change, this is the other concept I really wanted you to take away from today's lesson. Is the distance between f of theta and the origin increasing or decreasing. So this is going back to this row. We are going to answer this question based on not a graph, but this information that we're going to pull from here. So is the distance increasing or decreasing on this interval right here? So let's go up and find that interval. So from pi over 2 to 2 pi over 3. So I'm going to use red for this. I'll make it like this. So between these two right here, what is happening? Okay, is the distance increasing or decreasing? Are we heading closer to the pole or x-axis or further away? So two things tell us that. First, what is the r? R is what from -3 to -6? Are they positive or are they negative? Negative. R is negative, and the graph is, now you're going to tell me if it's increasing or decreasing. How can we tell that? So negative is important, and whatever we put here is going to help us answer this question. How do we tell? Are we going up or down here? Well, let's start over here. From 3 to 0, think about it. 3 is higher than 0. So going from 3 to 0, we're decreasing. Then from 0 to -3, we're still decreasing. What's happening from -3 to -6? Still decreasing. Think about where -6 is on your, think about where -3 is, and then -6 is down further. So if we're at -3 and then we're going to -6, we are decreasing. So R is negative and decreasing. Do those two characteristics match up? Yes. Remember, negative and decreasing go together. That means we are doing what? Increasing. Good. That's what I was saying was so important of that chart. And there's a question like that on your test. Okay? So knowing those characteristics. Okay. So finally on to the homework. Last homework in this packet. Which is the page you just grabbed by the front door. Yeah. Mm-hmm. So the paper that you grabbed by the front door, right here. I already labeled it for you and everything. Because for some reason page 188 got left off of your. Okay. So it's either blue or green or purple. I've used a lot of different colors. Everybody have it? Okay. So let me tell you what you're seeing here, because some people missed this part and were super confused. She's being mean. Jean Adams, who made this, she's being mean. She's telling us to find this A rock on two separate ones. So this is like two problems in one. It's doing this, whatever, doing this twice in every problem, okay? I just don't think we need to do that many of them, so I'm getting rid of the second one. Let's just find the A rock of this, and this, okay? And I'm going to do the first one with you, because you'll notice it says, well, if we don't have a table of values in front of us, even though you can use a calculator, you're not going to be able to use a calculator when you plug and chug on the test. So let's practice. What we need here is we need the R's. We have the thetas, but remember, for this formula, we need the R's, the change in R. We don't know what R is. So we're going to plug in these two thetas into this formula and find R. So R equals 5 sine 2 times, let's do pi over 4. And then we'll also find R by plugging into the equation pi over 2. So I'm just plugging in pi over 4 and pi over 2 for theta, and using my unit circle knowledge to answer this question. So this would be 5 times sine of pi over 2, 2 pi over 4, that's what that is, simplifies to this, and pi over 2 has a sine value of 1. Okay, so I get 5 times 1, so R is 5. Twos cancel, sine of pi is 0. Sine of pi is 0. So we have 5 times 0, which is 0. Okay? Now I have everything I need to plug into my formula, which is the change in r's over the change in thetas. So it doesn't matter which one you do first. I'm just going to keep it as second minus the first, just, I don't know why, just because. So 0 minus 5, r's, and then this would be pi over 2 minus pi over 4. So we get negative 5 on top. We need a common denominator on the bottom, which would be 4. So we would get 2 pi over 4. Keep, change, flip. We get negative 20 over pi. So she wanted you to do 2 of them in that problem. I'm just getting rid of the second one, okay? Well, you could write out another sheet of paper, but yeah. So my key has both answers, just so you know. I highlighted just the first one, so you only have to do it. But if you wanted more practice, of course, you could use this key to help you with the others, okay? And it does ask, since I didn't make you do both of them, it is asking which one changed faster. So if they're the same, they change at the same speed, right? Whether they're both positive, both negative, or different. So if you had found both of them, you would have had to answer that question. This one would have been faster because it's bigger. This one would have been faster because it's bigger. Okay. But just do the first one. Now the work's not shown. You need to do the work just like we did on number 5. Okay? So you're going to do that for 6, 7, and 8.
Real quick, on
Yeah.
5, how do you, so, I'm going to understand this because, how do you, like, move the sign pi over 2?
Well, from here to here?
Yeah.
Well, what is sine of pi over 2?
That's,
1. Right? Sine is your y value, right, in an ordered pair. And so pi over 2 is up there, so sine is 1. So I just replaced sine of pi over 2 with 1.
okay.
And 5 times 1 is 5. So sine of pi was 0. So that's where sine of pi went, being 0. 5 times 0 is 0.
Okay, all right.
You sure?
Yeah.
Yeah. It's using your unit circle knowledge. Y'all's favorite. I didn't lie to you when I said you had to know the unit circle really well. I was not lying.